All right, I'll get started. So the title of my talk is Wardley Maps and Flow. And this is it's a story about one of the consulting services that we have developed in the company where I work. It's a company called Rhubarbs. In my everyday life, I am a consultant and we do things around innovation management, R&D, strategy, that type of thing. Quite a few of you, I think, are from the agile, let's call it the agile world. So a number of things here might be very familiar to you. If you're not from that world, maybe there are some new things. But my intent here is to show something that we did and the results we got from it. And hopefully you can take some of that with you. Let's start. So Wordle Maps and Flow. Please stop me at any time if you have questions or comments, or if I say something that you don't believe in. So the first thing is Wardley Maps. And I don't know about the rest of you, but when I found Wardley Maps, of course, I thought it was amazing. It answered so many questions for me. I mentioned I'm in innovation management. And for innovation management and innovation strategy, Wardley Maps is just a revelation. And you have all these fantastic patterns with the ILC, and you have pioneer settlers and town plans, and all of these fantastic patterns. But as a consultant, and especially if you have a new client, it's difficult to get to the point where it becomes sensible or even believable to talk about these types of patterns and these types of initiatives, at least for me and for my colleague. So we needed to, since we wanted to use Wardley mapping, we needed to find other approaches where Wardley mapping could be useful. And one of those is when we think about flow. The idea of flow is fairly old in management knowledge and literature and whatnot. And at least for me, and again, this is not a scientific history of flow here, but for me at least, one big part of flow comes from what I tried to illustrate here. Does anyone know who I'm trying to show here? Any guesses?
Everything is changed, is fluid.
Yeah. So this is actually an attempt to showcase that this is Taiichi Ono. And he is the big brain, or at least a big leader behind the Toyota production system. And in the Toyota production system, we talk a lot about lowering the river to see the stones and to remove the stones so that the river flows better. So in the Toyota production system, which has then become what is commonly known as lean, of course, you often talk about removing inventory. And by removing inventory, you uncover the bottlenecks and the constraints to deliver value to your customer. So that's one side of flow, and especially so in production systems. Yeah. So there's a lot of talk about rivers and stones there. The other approach, one of the other approaches to flow, is something called theory of constraints, where we think about the system that we're trying to improve and where we're trying to have more things come out as some sort of process where we have a bottleneck. And the bottleneck can be just some part in a production system, for instance. In the wider scope of theory of constraints, we talk about constraints rather than bottlenecks, and constraints can also be things like policy decisions and things of that nature. And these are two well-established schools of thought when it comes to flow. And they really work quite well, especially in manufacturing environments. And once you dive into this, you start to understand that there's a whole science behind how it works. When we think about flow, and this is true for a Kanban system or a Scrum system or an XP system or whatever, what and how fast that system is moving is dictated by the mathematics of queues. And the fellow you see here is Dr. Little, and he proved what's called Little's law. And Little's law dictates how things move through systems. So it could be, for instance, shoppers in a supermarket, it can be parts in a factory, or as what I'm going to talk about, it can be projects in a project environment. So there's going to be some equations now. Don't be too scared. It's pretty straightforward. But Little's law essentially says that the stuff you have in the system is directly proportional to how fast you work and for how long time it takes to get the inventory through the system. So we talk about inventory, flow rate or throughput, which is the R, and then we have the average flow time. It's also we also often use the term cycle time, T here. And this is an equation that holds for most systems. There are some caveats about it has to be stable and it has to be measured in a certain way. But by and large, you can approach a system and this will be valid. Now, you can't really use this to make predictions. So if I decrease the inventory, will the rate go down and the time go down in the same amounts? Not really. If I decrease the inventory, all we know is that the system will balance itself again, but we don't know exactly how. But those are just caveats. So for the most part, we can understand what goes on in a system using Little's law. And why is this neat? And why is this important? And why is this a good mental model? It helps us to understand what we need to do to go fast. So here is a kind of basic example where we have a portfolio of 9, let's call it 9 projects. And in the first version of the way we execute this portfolio of 9 projects, we do 3 projects at a time. And in the second version, we do 9 projects at one time. We multitask 9 projects here in the bottom one, and we multitask just 3 in the top one. And this is a situation here where we have no variability, there's no noise, nothing. So it will end up with, we create the value from the projects at different times. So in the first case, we get a staircase here until time 9. And in the second one, we get everything at time 9. Why does that matter? We finished all the projects at time 9 regardless, so why care? So if we have value that is being created and that keeps being created, that's stuck over time, or at least beyond the last time point in this graph, it turns out in this very simple example, the total value we deliver during this time period is twice that in the top one compared to the bottom one. So the only thing we did was to execute fewer projects at any one time. The only thing we did, and the value for this time frame that we created was doubled. So that's pretty neat. Just by thinking this way, we don't have to do any change projects. We don't have to run any faster. We don't have to do anything in this simple project, in this simple example, to double the value. We just do fewer things at the same time. So in general, small inventory is good, but there are lots of caveats around just small inventory because we can't shrink it as much to see. If we shrink it to 0, we're going to do nothing. So there's quite a lot of caveats around when I say small inventory. But for most project delivery organizations, this is true. You can do less at the same time, you will deliver more value. Once you start to add variability and reality into the processes, you get a bit more of a complicated picture of Little's law. So what's important to understand here is that there is some sort of area. So we have on the bottom here, we have inventory or working process. And here the pink is cycle time and the green is the throughput. So in a more realistic picture, the throughput actually rises over time with more inventory, but we get to a plateau. So what we want to do normally in the real world is to make sure that we are in a sensible region in terms of how much inventory we have in the process. We don't want to be all the way to the left because then we have starved resources and we're wasting the resources we have that actually work on things. But that's usually not a problem in any type of knowledge work environment. And especially not if it's a traditional PMO, which is what I'll be talking about. Most of those organizations, like an R&D unit, for instance, which we work with a lot, most of them are way to the right. So they essentially have overloaded systems. So most of these theories are applied to production, and that's a little bit of a problem because they can be difficult to translate to knowledge work. And that's what we care about, or that's what we care about the most. But to alleviate that, I would call this sort of the Bible of how to achieve flow in knowledge work. So this is Don Reinertsen, and this is a very dense book on how to create flow in product development. I think you can probably translate this to almost any project organization. And Don, in his book and in his general approach, talks about 7 points to improve flow in knowledge work. So he wants you to understand your economics, make sure that how profitable or unprofitable things are going to be, or at least you have some sort of general idea about that. You have to manage the queues in the system, so you understand how long something stays in the system and how fast it gets delivered and so on. He wants you to exploit variability, which is just a fancy word to say that in product development, especially, you can pay a little to learn a lot. And then if you learn that something is very valuable, you can keep betting on it. And if you learn that it's not very valuable, you can stop betting on it and just cancel it. You want to enable smaller batches. So that's the same thing as in the example I just showed with Little's Law. We want to control the overall working process and the start rates of the things we put into the system. So we don't want to put a lot of projects in. So this batch size and the control of the WIP is very tightly connected, even though they're not exactly the same thing. Then he wants you to prioritize based on economics. So if something is worth more than the other thing, we should do the one thing that we believe is worth more. And then we want to have fast feedback. These are generally useful patterns for improving flow in knowledge work. And when I think about generally useful patterns, it sounds familiar, right? So we have our main man that has the similar thing. So to me, this is doctrine for flow that we will get back to. The interesting thing then is, how does Wardley mapping come in to address this doctrine? For us, we've done this mostly together with the project management offices, so PMOs. And we actually made a little bit of a Wardley map on the PMO's situation. And notice we have non-standard, it's one of the standard axes here. And I will step through this pretty quickly so that we make sure that we get to the more interesting stuff at the end. But a PMO in general, they have a portfolio of projects of some sort. The PMOs we work with are mostly R&D PMOs, R&D projects. But they want some sort of portfolio performance. They want good things to come out. They want successful new products. They want on-time delivery and so on and so forth. So portfolio performance is business value. They want to do it, deliver on budget, and they want to do it on time. And in most cases, at least what we've seen, budget compliance, especially in large organization, if you are over budget, you get severely punished. That's a big no-no, at least on a portfolio level. Business value is also relatively well established. At least most of the things that are being considered are relatively valuable and wanted by customers. There are varying degrees there, but on-time delivery, for the most part, for R&D portfolios are weak. Then to get on-time delivery and budget compliance, you need flow. So you need things to move fast and don't get stuck and so on. And to get business value, you need to have good project deliverables to make sure that the things that we deliver are the right things. We want, in an ideal world, to create changes for the better here. So we want more on-time delivery and we want better flow. So how do we do that? So you can, of course, achieve that in many ways, but the way we've mapped it out, at least, is that in order to get flow, you need to have some sort of balanced resource utilization. So a big problem with flow in large organizations is that people or certain, I've been told that you're not supposed to call people resources because it's derogatory, but in the interest of obviousness, let's call them that. So a resource, and in R&D, this is usually some expert. they get bogged down and they get called from so many projects. And that way the flow stops. So you get delays. In order for the flow to work, you also need a skilled project manager. If you have a very unskilled or a very green project manager, it's very easy for the projects to slip and for the flow to be disrupted. To get the project deliverables, you need a defined scope and goals, and you need a resource allocation. To get flow, you also need some sort of prioritization in the portfolio so you don't overload the resources. So there's the portfolio prioritization and the balanced resource utilization are very closely connected. And then another thing that happens in certain companies is that they don't really differentiate between explore and exploit projects, or rather, they treat everything the same way. So projects that might be far to the left of a Wardley map are treated the same way as something that is far to the right of a Wardley map, and that always causes problems. And to get through this then, so if you want to prioritize portfolio, you need some sort of decision function, and you need some sort of priority model that this decision function takes into account. And a decision function could be just a steering group, or it could even be software. But someone has to make a decision because there's always going to be more project ideas than we have resources for execution. So someone or something has to be deciding that we're not going to do everything. We have to have a prioritization. And to get there, to get this project priority, we need defined scope and goals, and we need differentiated explore and exploit. We need some sort of scope analysis. And to get the balanced resource utilization, we need some sort of availability model. To get project priority, we need the scope analysis, we need the strategy, and we need criteria. And then to get resource allocation, we need resource and competence availability. Now, if we can do something here, so with this map, we actually identified that scope analysis, which is usually not done very well, if you improve that, you get a lot of benefits. That goes all the way, because if you have a scope analysis that works well, you get better project priorities. You do differentiation between explore and exploit much more. For instance, in an R&D setting, you will do more pre-studies or exploratory things before you make big projects. You have better project priority, which means you don't need as much balance. You don't overload your resources as much, and so on and so forth. The scope analysis is a big thing. Now, we, of course, believe that scope analysis should have three things. So it needs the level of evolution, the doctrine of useful patterns, and the value chain. Essentially, what we're saying is that scope analysis, there's very few tools that are better for scope analysis for projects than Wardley mapping. So that's what we've done. So what I would like to show now is an example of what we've done with a large industrial company. And the information here has been anonymized and become made very generic so that you won't be able to tell which company it is. But I think given they're fairly generic, but also very typical of what we could see in a digital project portfolio in a large company. So the first project, so what we did is we did the scope analysis for 3 projects in a digital portfolio. And this was 3 out of maybe 25 or 30 projects. So this was like a proof of concept of using Wardley mapping in portfolio management. So the first project we looked at was it was considered a sort of well-run project without any major issues. And we did a mapping session for it, and we couldn't really see anything wrong with it. It seemed like if we went through the doctrine, they knew their users, they knew the details, and so on and so forth. But we'd actually learned a lesson from this, which I will come back to once we've talked about the other projects. So, big disappointment. There was no Wardley map here. But the second project we did was a machine learning project that had not been started yet. And this is another learning that when you do scope analysis using Wardley mapping, it's usually easier to get results and make changes if the project isn't started yet. What we had was something like this. So we have a prognosis team, an application engineer, and an R&D and design team. They want to do some sort of statistical historical performance. They want to have predictive maintenance assistance. They need customer knowledge, observation for customer support. They need historical data and reports, events. They want to have a forecasting solution that needs data exposure and a database, which needs a data model. There's going to be a data analyst involved here that needs a custom extraction tool, that needs event reports and a report tool. It needs to send notifications. It needs product data sources. It needs automation, machine learning engines, integration, standardization of customer service reports, and so on. So when you see this, those of you in the audience, is there anything that stands out as risky here? I actually can't see you. If there's no one there, it'll be interesting. But there we go. If I close that, maybe I'll be able to see if there's any of you left. Yeah, there's a few of you. What do you think?
We can't see it anymore. But...
you can't see it anymore. What about now? Can you see it? All right.
The extraction tool has a lot of things depending on it.
Yeah. So there's a lot of stuff to the left and pretty far down. And this is when we did the actual exercise, there was a lot more. We did it in Miro. There was a lot of things to the left that were going to be built in the project. It's far to the left and far from the users. So that's a big question whether that has to be that way. And once we asked if that would have to be the case, the people involved were actually like, oh yeah, no, we don't have to do it like that. So the data exposure, for instance, that they were going to build, they could just use a standard solution, turned out. And the custom extraction tool, they didn't need to build that, it turned out, because they had a standard extraction tool already. And they didn't need to do this particular integration over here because they could use an existing API. Great. Which means that once we tallied it up, it means that 50% of this project could just be replaced. And we could do relatively straightforward, simple integration instead of building things from scratch. So that's fantastic. Okay. So the third one then was another digitalization project, which was a bit more challenging to figure out. We had a big map, and this is not the whole of it even. Very complicated. We did the mapping in a relatively large meeting. There was like 10, 15 people in it. And it was hard to get a grasp of what was going on. We had lots of details in some areas. We had missing detail in other areas because there were stakeholders that at least some of the people in the project thought were users that were not represented. We had disagreements in the group on the exact scope of the project. So what was actually going to be achieved. At least it was very difficult for us as outsiders to understand that. And the scope was very broad. So the thing that they were going to build was going to be a lot of things to many different people. And we had a hard time trying to put this together and get something out of it. But then what we did is to start to think in terms of doctrine. And in this case, it's Wardley's doctrine, not Don Reinertsen's doctrine. And just looking at level 1, we could start to provide some insight to ourselves and provide some recommendations for what to do. We essentially went through all of these things to figure out, okay, what can we do here? What do we need to do in terms of these patterns in order to get this project into a better state than it is? These are the questions that we asked. So know your users. There's lots of users that they want to serve, but they don't know what they do, right? So let's focus on the users they do know. Understand why the users want to use the system that they're building. You should probably look at it a second time to understand, are we building the right stuff? And so on and so forth. Also, think small. So I would say this particular project is a classic example of a Death Star project. You want to build this big jumbled mess of things. And they were talking about it was going to be a minimum viable product approach. But in the workshop, it was pretty clear that they were going to build a big monolith of something, which it was doubtful whether that's going to work very well. If we then take that into consideration, we simplify the picture a bit. So we changed it to 2 core users. We identify the core of what needs to be built, which is this product life data thing. And what is really needed for this to be built out is to go from the existing data sheets that they were going to use. So they have data sheets in PDF form that the engineers create. They need to get all that data into some sort of database, and that database can be consumed by whatever system or whatever user in the future. And then we get a much clearer picture, and we get a clear Wardley map. So we have two core users now. So the service organization and the product engineer. The service organization wants to do a service engagement where they want a custom service plan for that engagement, which today that's custom built. You have product engineers. They want to update the product lifetime models that goes into these custom service plans. And to do that, because the product life data is dependent on that. And we understand that the core of the project is to create this tool for custom lifetime assessment. The big thing about it. And through that, if this exists now in a good way, the product life data can actually become consumable by other systems. And the updates of these lifetime models becomes much easier and much more reliable, and so on and so forth, which also then enables things to be built on top of it. Because if they were going to build this tool now based on lots of data down here to the left, and again, this is a recurring pattern that trying to build something new on something relatively immature or unstructured down below, it's not going to work. And in fact, it doesn't work because this project has been going on for a long time and it's not getting anywhere. And in the state of form it was now, we would not have let this through into the product portfolio. If we then look at the sample evaluations that we did, we had one project that was fully thought through. We would probably not have changed it. It would probably have gone into the portfolio. One of the projects had a major shift of content, and we estimated that to be 50%. And one project we would not have let into the portfolio at all. And that project is running now, but it's not producing any results. So we would have been as well off without it. So we went from 3 projects to 1.5 projects, which is 50% or 50% reduction. And we could at least argue, this is not something we would claim with our lives at stake, but the value delivery more or less could be doubled by doing this. And even if it's not double, we for sure will make much better choices for which projects to start and have fewer problems with the projects that we start. So we believe that it's Don Reinertsen will be happy. So by using Wardley maps in this context, we actually help managing queues. We can remove a lot of things that we would have put in as WIP batches. We can remove things in the projects that will become activities that we need to do, which we actually don't need to do. It helps us control WIP and start rates. It accelerates feedback and so on and so forth. And all of this through Wardley mapping. And what has this led to? So this particular company or this particular unit is actually doing Wardley mapping now as a part of their development process. And I was there and participated in a few sessions. They're just getting started with it. And as far as I can tell, they're having pretty good results with it thus far. So some of the lessons learned from us. So the first thing is that it takes quite a lot of time to map, especially when you do this in a group setting. And what I find is that it usually takes around 4 hours. And that's a pretty tough workshop to run and be part of. So it's usually a good time. I know Simon talked about this in the plenary session here, that 2 hours is enough. So if you come in as an outsider to do the facilitation of Wardley mapping, try to divide it into 2-hour workshops. So that's something for us, but you need the 4 hours, otherwise you will not finish. And the other thing that we learned is that you shouldn't skip the circle. In the beginning, when we did Wardley mapping with companies, we jumped into doing the maps. because we felt we didn't have time to go through all the thinking and all the modeling and so on and so forth. But what we tended to miss then are two things. So the first thing we tended to miss was the purpose. And in terms of a project organization, this is quite important. So asking, what's the purpose of this project, can be quite revealing, because a lot of times in a large organization, it's quite unclear what the purpose of a project is. Not all the time, but quite often. And by asking that question, we really have a chance of avoiding doing things we shouldn't be doing. And the other thing is that the doctrine really helps. So it helps when things get murky or complex, but it also helps with just the coaching and understanding, okay, what should we do next? Think about doctrine then. So doctrine is very powerful, both in terms of flow from Don Reinertsen and also from Simon, of course. And then the last thing is in terms of consulting, and when you have projects with Wardley mapping, at least in my experience, is that you need to be a little bit lucky. So you need to have a map that becomes at least decent so that you can find some obvious insights that they didn't have before. And it's always easier to change things if you do this. If you apply this to projects, it's easier if you do it before projects are started. Once projects are started, you have all this sunk cost fallacy, all these political entrenchments and so on and so forth that can make things difficult, even though the map tells you a pretty obvious picture sometimes.
A question. Is using the map clear to the management that you are dealing with? The concept, can they grasp it and validate it before you start going?
So what we would do here is the management here would be part of the first sort of trial experiment. So they will be quite well read on Wardley mapping. So they know. And then also we show some of the more simple and obvious examples. Like, I don't know if you remember the Simon's Elvish graph. So there's a graph with Elvish, and okay, how do you know which one, and so on and so forth. So how do you make choices when you don't? It's difficult to make choices, but if you have a map, it's easier, right? And then there's also the examples of decreasing the need for capital in the train projects or the public rail projects that we tend to show. But do management completely understand everything before we start? Maybe not. But they understand enough that if we manage to get it, there's going to be value coming out, I would say.
Thank you.
Let's see.
And two questions for you. One is, in terms of flow,
yeah,
project is a little bit of in a way. When it's more around product and initiatives under products, typically flow. Have you been able to, and the whole project organization, PMO and so on office is really taking a very different look when you talk about products. Have you been able to map that difference at any point?
I have not, but what I would say is that I think if you would start from scratch, a lot of the practices of product development or R&D in large organizations, that you would do it another way. So what we try to do is to come in and provide something that can be done given the very large inertia around how things are being done in these organizations.
I'm not saying what you've done is very useful, and it's a very interesting take. I was curious whether you took it even to the stage of changing and saying, actually, projects is not the best setup.
So we have not done that. I think the more you get into this, the more obvious it is that a lot of times a project organization is not really the way things should be set up. And that's also, I think, Don Reinertsen too is saying that the way we are organized to develop products is actually not the way we ought to be set up to develop products. But I mean, we just try to live within the system.
Yeah, that's fair enough.
And I think also when it comes to digital products, and if you look at the companies that have more digital offerings than the ones we work with, they're going more towards an agile type of implementation rather than, so what we look at here is very much like the waterfalls of waterfalls, right? Whereas you have a lot of things for free if you do a more standardized, if you do a standardized agile approach, even that's going to have problems too. If you implement Scrum or whatever you implement, it's always going to have a problem, but you get a lot of benefits from that. Especially the width is always going to be limited to do that. But yeah, so I think there's lots of things to uncover here, and lots of things to change if you really want to look at flow from these in this context, for sure.
My second, thank you. And my second question is taking it a step further. I always had the idea of looking at maps for architecture. I never really got into the details of it, but the idea, and I've seen that you rename the labels as well, and looking basically at labels like experimenting, like consolidating, maintaining, and retiring type labels on the map, and looking at your projects and determining, so this is the flow of value. This is how much money we're going to put in those places, and where are they? And is there much money going towards things we're supposed to retire? And basically doing architecture maps of that nature to visualize where is the money going? Are we actually progressing the architecture as part of doing those projects? And are we throwing a lot of money after that, in a sense, if you can still developing on things we're planning to retire?
Yeah, I think there's a lot of merit to that.
Mhm.
Because what you typically see, and you don't necessarily need to do it in a map, you could do it in other ways as well. But if you look at the balance of the budgets that are being spent, the balance is usually off somehow. So either you spend too much on very sustaining projects, or you spend too little on sustaining projects, or if you have some sort of strategic intent with your portfolio, you spend everything in one strategic initiative and nothing in the other strategic initiative. Because a lot of times the people that are doing the execution and actually doing the selection of the projects, they're further down in the organization and they're not really aware of be it a good or bad strategy that the organization has, but they're really quite not that aware of it a lot of time. So this balance can be quite off. It's like I'm starting to get to a realization where I think the incentives for the people in the PMO, and this is just colored by my own experience, of course, but the incentives of the PMO or the people in the PMO are not that closely aligned with the incentives of the company as a whole. So in the PMO,
That's
that's
where you
another.
pivot from delivery is the goal. The business is no longer in the equation. It's just somebody else is holding that equation of delivery to business value.
Exactly.
And at some point, it gets lost into the layers. Yeah.
Very much, and especially if you're in a very large organization.
Thank you.
Any other questions?
I just wanted to pick up on something you were saying when we were looking at one of the maps.
Yeah.
You were talking about how there was a lot of things concentrated in the bottom left.
Yeah.
And I thought that was quite interesting in terms of, do you see that as like a more general pattern? I was think of in software development where you have code smells. If you see a lot of stuff concentrated in the bottom left there, is that kind of a
it's actually much more common than I ever thought it would be. When I learned about Wardley maps, I'd never done this and I hadn't thought about anything in this way. And then we started mapping. So we've done it for, I don't know how many organizations, but it's extremely common. And we've also done mapping on a more, like a slightly higher strategic level for product strategy, product portfolio strategy. We've seen quite a few cases where the old strategic advantage of a company or the competitive advantage is the fact that they have something that is far from the customer and far to the left. And then when we ask them, so this thing that you do that you're very good at and that's a competitive advantage for you, is there any way you can do it? Is there any other way you can do it in the world? And they're saying like, oh yeah, definitely there's like an open source version of this. It's coming. It's like, are you not worried about that? No, they can never do what we do. But once you learn Wardley mapping, it's just such a huge glaring red sign of danger, right? So we see it quite often, I would say. And so it's either you have a competitive advantage that is far to the left and far from the customer, or you're trying to build something new on a system that is just disordered. Or the case I had here is that they have a collection of PDF files of different sorts, and they're trying to build on-demand service on that. And it's just never going to work.
Yeah, I thought that was interesting. I think you said something to the effect of it's quite dangerous to build on top of that stuff that's in the bottom left.
Yeah, and I don't know if it was Dave Anderson. I feel like I've seen this from someone smarter than me, is that the lower left quadrant is like the quadrant of death. Because you don't want anything in the lower left quadrant, essentially. Unless it's something very specific and you have a very strong competitive advantage and no one else can do it ever. But very few things in this world are things that no one else can ever do ever.
It would be fair to say then, if you've got something over on the left, you want it in the top left is the sweet spot for where you want to be. That's where you want your competitive advantage to be, right?
Yeah, I mean, ideally. I mean, you can have the competitive advantage anywhere. So, I mean, AWS has a competitive advantage and they're far down to the right, or for most people. So that's okay too. And they have a scale advantage, which is great as well. Or you can have something that's close to the customer, which is new, exciting, high value per transaction, so on and so forth. But it's very common that you have a relatively commoditized product and you build it on something that is very custom made. And it's not a long-term situation you want to be in, I don't think. Of course, you can never tell exactly how long it will last, but it's a difficult situation.
It's at least a question you should ask yourself. Sometimes the opposite of that is Toyota tended to have their own jigs and so on, because what they would buy would do considerably more than they need.
Yeah.
And therefore the investment wasn't justified. So they had the reason to keep something custom to the left.
Yeah, for sure.
And they could create their own tools and things like that. And you would say, tools you buy. But at least they had a reason for that.
Yeah. And in their case,
that's not true.
Yeah. And in their case, that custom made jig enabled the SMED or single minute exchange of die or something like that, which was not possible with a standard offering, probably. And then that's their competitive advantage, is that they have this system of flow and they need these tools to actually enable that. And but again, I think one of the things that Simon says, and I completely agree with this, that there's no one size fits all, right? You can't just say, just because it's to the left, it's a problem. But it's more likely that it's a problem if it's down to the left than if it's somewhere else. And it's something that, as soon as I see it, at least now, I question whether it should be there or not.
If you find a reason to have something in the bottom left, it means that there is probably a need in the market for it as well.
Yeah, probably.
And you may have something you can spin off as an offering in the market, as something underpinning other people.
Yeah, exactly. And you could potentially have a first mover advantage, given that you if you cross from custom made to product, or if you cross from product to commodity. For sure.
Interesting. We're saying it's not necessarily a problem then, but it's something that you need to dig
It's not necessarily a problem, but if you're not aware that the fact is it's completely defensible, it's probably a problem. So if you're aware that no one else can do it, or there are no other alternatives of doing it, or it's too difficult to do it, or I don't know, then fine. But most of the time, once you start to look outside, you find alternatives a lot of times. Or at least that's the experience from the engagements I've been in. All right. if there are any more questions, I'm happy to take those. Otherwise, I will let you have a cup of coffee and then we'll go into the next group of sessions, I guess. Thank you for the very nice questions and for the very engaging discussions. Thank you.
Thank you for your time and sharing with us. Cheers.
Thank you.
Thank you.